Hi everyone, my name is GOH JUN YU. Today, I would like to present about what I have learned and done in my assignment 1 of computer programming. Problem A1, MATLAB as a calculator, I have learned how to solve problems by writing commands in the command window. To solve question 1a, first I have to define my variables which are a equal to 30.5, b equal to 7.2, c equal to 4.3, d equal to 49, e equal to 3 and f equal to 15. Then I write the equation in the command windows and press enter. Then I will get my answer 15.5889. Same with the method to solve the question 1b, c and d. For question 4, I use the method of left hand side and right hand side. First, I define my variables x equal to 12. Then I write down the left hand side equation and get the answer 0.7431, same as the answer of the right hand side equation, which is 0.7431. Same method was using for question 4, B, C, and D. At the end, I will get the same value at the left hand side equation and the right hand side equation. Next is the problem A2, creating and modifying array. For question 2, we have been asked to create a row vector and do not type the vector explicitly. First, we define our vector as A1 and A2. Then, we combine them to create the vector B. Then we will get the answer. For question 4a, we have been asked to create a matrix which the first, second, and third rows consist of first three elements of the vectors a, b, and c. First, define our vector a, b, and c, and then we create a vector which consists of vector m, b, and c in the type of columns. For question 4b, we need to create a matrix which the first, second, and third columns consist of last three elements of the vectors a, b, c. Same step with the question 4a, and then we change the sequence of the vector from right to left, and then we combine the vector, we will get the final answer. Next is the problem A3, matrix operation and manipulation. For question 1, we have been asked to find the value of y by using the element by element operation. So the first step is we define our x value, which is from -3 to +3. Then we write down our y function, and then we will get the values of y. Same methods using for the question 2. First, define the x values and then type the y function. At the end, we will get the values of y. That is the problem A4 script file. In question 1a and b, we have been asked to write a script file for our following problems. For question 1a, we need to calculate the radius of sphere. First, our input is L, and our surface area of cube is A equal to 6 times L power of 2, and then we'll create a function to find the radius of sphere, which is R1 equal to square root A over 4 pi, and then we save our function. Then we run the function, we will get the radius of the sphere, which is 4.8369. Same method using for the question 1b, we write down our input L, and then define our function which is volume equal to L power of 3, and our equation which is radius of sphere R2 equal to 3 times volume over 4 pi power of 1 over 3, and then we save our script file and run in the command window. We will get the radius of sphere, which is 4.9628. For question 3a, we need to write a script file to find the bending moment at each load point. So our input is load P1, P2 and P3 with distance x1, x2 and x3. Then to find the moment, we need to times the load with the distance, and then we save the script file and run in the command window. Then we will get the bending moment at each load point. For question 3b, we need to find the bending moment at start and end point of the load. So our input is Q, which is value of load, and input A, input B, which is value of distance. Then our moment at start point, which is value of log Q times with the distance A. Then we save the script file and run in the command window. We will get our bending moment at start point of the load is 1000 kN per meter, and bending moment at end point of the load, which is 2000 km per meter. And the last one is the proven Fi, simple 2D plot. For question 1, we need to plot a graph for our function y with the given x value. First, we divide our x value, which is -3 to 5, and then type our function y. We will get the values of y, and then we plot the graph with the dash magenta and the light white with 2 and marker size 10, and our marker face color is blue. For question 2, we need to plot the function y with the different range of x value. For the first one is value x is 0 until 3, with the difference of each is 3/8, and then we plot the graph. This is the graph for the x value from 0 to 3. To plot another graph for function y, we will use the same method for the first one graph, but with the different range of x value, which is 8 until 15. This is the graph I get from the function y with the range value x of 8 until 15.